Assalamu alaikum, my dear colleagues. I'm your physics teacher, SHABAN. Today we are going to study chapter number 4, motion in two dimension. Our topic is angular velocity. In this topic, we will discuss about the definition of about angular velocity, its definition, its explanation, derivation, its SI unit, and the relationship in between angular velocity and linear velocity. So first of all, we are going to start angular velocity. Its definition is the rate of change of angular displacement is called angular velocity. We have already studied about the displacement, angular displacement, and its relation with linear displacement. Now we are going to study here the angular velocity. As we know that in a linear velocity, the rate of change of linear displacement is known as the linear velocity. In case of angular, the rate of change of angular displacement is called angular velocity. Angular velocity वो होती है जिसमें एंगुलर डिस्प्लेसमेंट किसी यूनिट टाइम में चेंज हो रही हो हमारी, उसको हम एंगुलर वेलोसिटी कहते हैं. Angular velocity also defined as it is the change of angular displacement of a particle in unit time when the object possesses circular motion is known as the angular displacement. Suppose, as in our previous lecture, we have already studied that the angular displacement is the angle possessed by the body while it moves or revolves in a circular path. That is called the angular displacement. Now, when this angle changes with unit time, suppose object completes its one rotation in 5 minutes, and in other attempt it completes its one rotation in 3 minutes. We can say that there is the change in its speed. Definitely, the angle possessed by object in different interval of time, such angle, such circular motion, such rotation possessed by the body in a different interval of time. That's why we can say that it is the change of the angular displacement in unit time. We can say that it is the angular velocity. जब कोई ऑब्जेक्ट गोलाई में कोई हरकत कर रहा होता है, उसकी वही हरकत किसी भी टाइम इंटरवल में चेंज हो रही हो, तो हम कहेंगे उसको एंगुलर वेलोसिटी. एंगुलर डिस्प्लेसमेंट ऑलरेडी ऑब्जेक्ट पोजेस कर रहा है जब वो एक हरकत कर रहा है अपने सर्कुलर पाथ में, लेकिन एंगुलर वेलोसिटी हम तब कहेंगे जब वही उसकी एंगुलर डिस्प्लेसमेंट किसी भी यूनिट टाइम में चेंज होगी. डेफिनेटली हियर we are going to start from this point. Here is the radius or and object start to move from this point where its velocity will be considered as vi, and here is another point where its velocity will be considered as vf. This velocity is vf and this velocity is vi. We can say that there is the change in this velocity. There is the change in between 2 points. Here is the angle possessed by the body which change in per unit time. That's why we can say that it is the angular velocity. The angular velocity is denoted by omega. Angular velocity is equal to the angular displacement upon time taken. जैसा कि मैं पहले मिसाल दे चुका हूं कि जब कोई भी ऑब्जेक्ट गोलाई में एक हरकत कर रहा हो और उसी हरकत में वो अपना टाइम जो है वो डिफरेंट ड्यूरेशन दे रहा हो, हमें एक में 5 मिनट दे रहा है, दूसरे में 3 मिनट दे रहा है, तो हम कहेंगे वो जो डिस्प्लेसमेंट है सर्कुलर पाथ की वो तो सेम ही है. उसमें जो टाइम चेंज हो रहा है हम कहेंगे कि पहले में उसकी स्पीड ज़्यादा थी, अब सेकंड में उसकी स्पीड जो है वो कम है. जिसमें 5 मिनट ले रहा है हम कहेंगे उसमें उसकी स्पीड कम थी, जिसमें 2 मिनट्स ले रहा है तो हम कहेंगे उसमें उसकी स्पीड ज़्यादा थी. तो जो गोलाई की हरकत में जो ऑब्जेक्ट की वेलोसिटी होती है हम उसको कहते हैं एंगुलर वेलोसिटी. एंगुलर वेलोसिटी डिनोटेड बाय ओमेगा सिंबल. We can say in mathematical form, in derivation form, that omega is equal to theta upon t. Here theta is the angular displacement and t is the time taken. Angular displacement divided by time taken, we can say that this is the derivation or expression of the angular velocity. This formula gives us the average angular velocity of body over an interval of time कि एक शॉर्ट इंटरवल ऑफ टाइम में जो ऑब्जेक्ट है वो जो अपनी एंगल पजेस कर रहा है किसी भी यूनिट टाइम में हम उसको कहेंगे कि वो हमारी एंगुलर वेलोसिटी को शो कर रहा है. नाउ वी आर मूविंग टू एक्सप्लेन इट्स unit SI unit of angular velocity. As we know that omega is the symbol of angular velocity. Here omega is equal to radian upon second. Radian for angular displacement and for second the SI unit of time is second. We can say the SI unit of angular velocity is equal to the radian upon second. We can write this in this form: omega is equal to radian upon second, or in degree form we can write this: omega is equal to the degree upon second. तो वो जो ऑब्जेक्ट की वेलोसिटी होती है सर्कुलर पाथ में हम उसको कहते हैं कि वो ऑब्जेक्ट जो है वो ऑब्जेक्ट गोलाई में जो अपनी वेलोसिटी दे रहा है हम उसको नाम देते हैं एंगुलर वेलोसिटी का. एंगुलर वेलोसिटी we can say that according to this definition or according to this equation that angular velocity is the ratio in between angular displacement and time. There is another definition. In this case, another definition: the angular displacement a upon time. We can say angular velocity is the ratio of angular displacement and time taken by the body to complete its one rotation or complete its duration in between 2 points. Now further, the relationship in between the linear velocity and the angular velocity. We must know that what is the linear velocity. It's clear that the rate of change of displacement is called linear velocity. So as from the derivation of angular displacement, we have already studied about S is equal to r theta, which is the derivation of angular displacement. S is equal to r theta, where S is the linear displacement, r is the radius which is constant in a circle, and theta is the angular displacement. Now here S is the linear displacement, theta is the angular displacement. Again we are moving towards the basic definition of the angular velocity, that it is the rate of change of angular displacement. A rate of change of means any quantity which is divided with unit time. Here the meaning of rate of change of means any quantity which is divided with unit time. It means angular displacement divided with unit time. Now same as in this case, here is the derivation: dividing by t both sides we get S is equal to r theta. We can write this equation in this form: S upon t, which is equal to the r and theta upon t. We know that S upon t is the displacement upon time. Displacement upon time is known as the linear velocity. S upon t is equal to the linear velocity, and also we have studied about the angular displacement, that when the angular displacement change with unit time, that is called the angular velocity, which is denoted by omega. Now here in this case, S upon t represents here v. We can write that instead of S upon p, or by substituting the values, S upon t is equal to v, which is equal to the r remains same, and angular displacement upon time denoted by omega, which is the angular displacement, where v is the linear velocity and omega is the angular velocity of the object. Here v is equal to r into omega is our relationship in between the linear velocity and the angular velocity, which shows the expression v is equal to r into omega. Now this is all about our today lecture, my dear cadets. It's the angular velocity. We can again say that angular velocity is the rate of change of angular displacement, that is called angular velocity. So wish you best of luck. यहाँ पे हमारा ये जो टॉपिक है वो एंड होता है। तो क्वेश्चनिंग के लिए हम इंशाल्लाह आगे जो है ना वो एक पोर्शन रखेंगे, तो उसमें आपकी क्वेश्चनिंग। विश यू बेस्ट ऑफ लक।